I just noticed nobody could hear me. Welcome, everyone. This is episode 7, the 8th episode of the Identity Show. We're going to keep talking about Swift. And I'm going to bring up this wonderful graph that we have here. So this is the range we're working with, right? And Swift is nice because it fits right in the middle. You can do low level stuff and you can do high level stuff. For now, we haven't seen we haven't seen where it falls in this line. So I'm going to tell you now what we've seen up until now is well, actually, it's hard to tell because what we've seen are like enumerations and structs, and you could say that they fall like right into here. But when you consider their theoretical counterparts, like the way they are understood as a mathematical tool, they are quite close to what we see in pure mathematics, with products, coproducts, projections, stuff like that, lenses. All of this is really close to this bit here. And that's good. That means that with the same tool, with enumerations and records, enumerations and structs, we can talk about stuff from here, and we can talk about stuff from here. Now there is also a line that goes through here that is a bit more complicated that we're going to go into today, and that is things like types, generics, and protocols. So last time, if I go through here again, and I click here, you can see that we have this colon here. So that's the well, I'm gonna motivate it first. We have this column here, and then we have this text that says custom string convertible, and that is a protocol. And protocols are really important in Swift, but also in general in programming. They're not called protocol everywhere, but the reason they are important is because they allow you to expose behavior to the rest of your program. And that's something we want to do at some point. We want to say, this is the kind of stuff you can do with a program, or this is the kind of stuff you can do with the data. And given this information, you can make decisions about how to write the code, how to use the code, and how to put safeguards. So for example, you can say, you can do this thing with this value, but you can't do this other thing, even though they look very similar. They're not quite the same thing. The other thing we have to see is types and generics. And we can see this here, or we can see here. We can see it here. So person, how to motivate this. So let's say person has a list of favorites, right? But we don't know what it is. It's well, it's more favorite. Rather, this person has a favorite thing. This thing, we don't know what it is. We have to give it a type though, because everything has to have a type. So we're gonna call it thing. We're gonna say whatever the thing is, decide what it is when you create the person. So if I say Jane, I'm gonna say, well, Jane's favorite thing. Oh, we're gonna make things to enjoy. So books, and what are books? Top 10 books of 2019. Come on. There we go. It's very slow. All right, we have this one. Come on. Actually, let's do it differently. Let's say it's a struct book, and the book has a title, has a release date, it has a rating, it has an author, and that's it. You're not gonna bother anymore with any more stuff. So we haven't defined rating and authors, so rating is gonna be really easy. Rating is just a value from 0 to 5. All right. And author is going to be very similar. Actually, author is going to be a person. But then we can have... Oh, you know what? No, that's fine. Type alias author is going to be person of void. Does that work? If that works, I'll be extremely surprised. Build failed. Where? All right. And her favorite books is The Testaments. The release date is... Wow. All right, it doesn't say. I'm gonna say date. Yeah. Can we remove 1 year? And time interval. Yeah, that's not helpful. Well, is it? It's all right. I'm just gonna say dates is now. That's fine. Oops. Rating is 4. And author is Margaret Atwood. And let's say Margaret is a person. Age, I don't know. What's the age of Margaret Atwood? She must be very old now. Oh, that's not very old. Wait, no, that's period. Oh, 80. Okay, she's 80. Yeah, that's old-ish. That's her name, Margaret wait, Margaret. Atwood, screw capital letters, is employed. Yes. Author. Hair length. That's medium, right? And favorites? No favorites. Oh, I have to. I'm gonna say, wait. I'm not gonna say void, I'm gonna say this thing. Favorites, this thing. All right, and now we put the author here's Margaret. And it works. Great, great. That's great. So what we did is we said Jane, it's a person. Her name is Jane. She's unemployed. Her hair is medium. She has a favorite book. And the favorite book has a rating, release date, author, and a title. And so the reason we did it this way is that this thing here could be anything. So if you want to change it, I want to say she really likes some kind of food. And we're gonna say she loves expired beans. It's plant. So what we can do is here we can replace that book by some food. Oh. All right, sorry about that. We can replace the food. We can replace the book by some food, and say the food has a name. It's expired. True. And it's plant-based. And here we go. And nothing changed. It still compiles. So, well, that's a bit too small to see. Can I do this? No, I can't quite. I can't zoom. Well, that's a shame. Let me change this. Accessibility zoom. Huh? Oh, there we go. So, what happened? Come on. So if you click on Jane with Alt click, you can see that Jane is a person that has a favorite food. But if I change it here, and I put book instead, well, if I just Control Z enough times, and then inspect the type again, it says it's a person that has a favorite book. And this works because we haven't said anything about the favorite thing. Just know that it's a thing. And this is inferred by the value that is here. So when it's a book, it's a favorite book. When it's a plant, when it's a food, it's a favorite food. And here you can see that for Margaret, I said favorite is parentheses. What does that mean? So if you look at this, the type is type of parentheses. And this is called the unit type. This is very important in type theory. So the unit type means it's a type that has only one value. So if you take, for example, a type string, it has infinitely many values. There is the empty string, a string with A, string with AB, string with ABC, string with A, etc. There is an infinite amount of them, just because you can make them of infinite length, supposedly. At some point you'll run out of memory, but that's not that's not what we're trying to measure here. We're trying to measure, like, if you had infinite memory, you could also have infinitely many, a string of arbitrary length. Or if you look at integers, there's also an infinite number of them, like, well, there's 0, 1, 2, 3, 4. Actually, that's not true. There is a finite number of integers, because integers are represented as a 64-bit number. And as we've seen before, 64 bits means you have 64 0 and 1s to put in a row. And so the maximum number you can do with that is 2 power 19. So int has 2 power 64 different numbers. And that amounts to 1.8 times 10 power 19. So that's 1.8 times 10 power 19. That's a lot of numbers. You can do a fair amount of stuff with basically 2 times 10 to the power 19. Now let's look at a simpler one. Bool only has 2 values, true and false. Or if we look at our previous type, rating, rating has 5 values. Has 5 values, 0, 1, 2, 3, 4, 5, and that's actually 6 values. It's no matter. Also, you notice that here, since we can change the favorite thing to be whatever we want, we can say her favorite things are ratings, right? If you zoom in, it says person, Jane is a person which favorite things are ratings, specifically the rating number 5, which is 5 stars. She loves 5 stars, 5 out of 5. Perfect, she loves that, and that's fine. Or the thing you could also say that her favorite thing is Margaret. Right? And now if you zoom in, we say, well, Jane's favorite thing, Jane is a person which favorite thing is a person. It turns out to be Jane. You can also tell that her favorite thing is a person whose favorite thing is the unit type. And why the unit type? Well, since the unit type only has 1 value, there is no information that you can put in there. There is only 1 value. So at least with true and false, you have 2 values. You can give a meaning to one of them. You can say, well, true, I will use true to indicate that something is actually true, or something is matters to me. And I will use false when I when I want to talk about things that either don't matter, or represent falsehoods, or represent errors, or represent things that I want to put aside. Or ratings, with those 6 possible values, you can define, well, this is a rating where it's so bad we haven't bothered putting in a star. This is 1 out of 5, this is 2 out of 5, this is 3 out of 5, this is 4 out of 5, and this is 5 out of 5. And so with 5 values, you can give it those meanings. But when you have only 1 value, you can't say, well, this value means something, and you can't say there's another value that means something else. It only means one thing. And when it can only mean one thing, it can't mean anything. You can't say, well, this means true, because then everything is true. Or this means Margaret, and then everything is Margaret. Like, there's no way to differentiate between this and this and this. They're all the same. And so you can say that's useless, right? Because since you can't carry in information, you can't infer anything. But in our case, we're using it to say, well, Margaret doesn't have a favorite thing. If she has one, we don't know what it is. It's just a way of saying it's there, but we can't really tell. Now, if you really paid a lot of attention, you will notice that I tried to yeah, there we go. I tried to trick the system. So here we said an author is a person that has no favorite thing. Then I said, and before that I said an author is a person that has void as a favorite thing. And void is really important as well. Void is the type that has no value. And I changed it because if you say Margaret has to be an author, then you have to put here her favorite thing. Like you have to put here a thing of type void. But we just said void has no value. So we have to put a value here, but void has no value. We can't make up a value. Like we can't just make one up. It by definition doesn't exist. And so this thing is impossible. You cannot create an author because an author requires a favorite thing of type void. You can emulate this behavior by saying I have a type that is an enumeration, and this enumeration has no value. And we'll see that we have the same problem here. If I put empty, I can't instantiate it. There is no value for this. So it's impossible to construct. So that's why I said, well, author is a person that has a unit as a favorite thing. And that way we can just say, oh, it's that. We don't care. It's fine. So this takes care of three very important things: void, unit, generics. So now generics, you might have heard of them, especially if you're in the Go community. When you're talking about context, like things like arrays or lists, here's the thing. I'm going to show you something that you should have probably seen if you've done some Swift. Those are optionals. So Jane, for example, is a person, right? What if we say that Jane has to have a favorite thing, but maybe she doesn't. Maybe she doesn't. For this, we could say, how to put it, like, we can make a new type that says maybe no favorites. And the value that we put here is either there's a favorite thing or there's no favorite thing. So either there is a thing or nothing. And we just saw that nothing, we can represent this with the unit type. And we've seen that thing you can represent by just saying, oh, I don't care about the thing, just call it thing and put this thing in brackets, and just we'll see about that later. Well, I can't quite use the syntax. And you'll see very quickly, because or is not a way of saying, like, there's no way of saying this type or this type. But Swift has a way of saying or nothing. And the way of saying or nothing is by putting question mark here. If I compile this, it works. And this is equivalent to that. It's sometimes there's a thing, sometimes there isn't. That's what optional means. Optional means that thing here might not be there. I'm gonna keep it with the question mark because this is how it's customarily represented. But let's take the example of Mark. Mark is also a person, and it's let's see, to complete. His age is 15. I'm gonna remove it. Name is Mark. Is employed is unemployed. Hair length is long. And favorite, we're gonna say it doesn't have a favorite. As a matter of fact, I'm gonna say maybe not favorite. Maybe it doesn't have one. There we go. Oh yeah. So, all right. Actually, let's see what happens if I do that. Yeah. All right. So now the problem is, person has to have a favorite thing, right? We just said, sorry, not person. No, yes, person. Person has to have a favorite thing. But since we haven't given it anything, it still has to know what this thing here should be, right? Oops. Like, it still needs to know what this is. And we haven't given it anything. We used nil, and nil means nothing. So remember, this is either a thing or nothing. We just said it's nothing. So it's complaining here that it doesn't know what the thing is supposed to be. So we're going to tell it. If it's something, might as well be a book. It's going to be a book. Mark is very likely to enjoy books. And this allows us to I'm just gonna testaments. I'm just gonna make it again. For Margaret. And now we can say, well, either it's testaments, and that works, or it's nothing, and that works too. Right? Pretty cool, right? But we have to tell it here that's maybe a book. If I put a rating here, like 4, it's going to complain and say, well, you said it was going to be a book, but books can't be 4. So you have to change something here. Either it's not a book or it's not 4. So either we say it's a rating, that works, or you change it to a book, and that works. So optional values are really interesting because they allow you to say either that or that. And as you've seen, they also use generics, because the way you want to say there is a value is, I don't actually know anything about the value. The only thing I know is that it might not be here. And you can very easily implement that. We're gonna call it maybe. And this is entirely equivalent to the question mark syntax. So maybe either has something which is the value, or it has nothing, which is the absence of value. And if I move this up, you can see that I can basically completely replace our use of question mark with maybe and say here, person maybe likes a thing, and Mark maybe likes a book. And either it's the testaments. Oh. Type of expression is ambiguous without more context. Oh, that's why. So maybe it's the testament, or it's nothing. And that works. We have exactly the same meaning as before. We've just replaced the question mark by this declaration of a type. And you can see we've used the same trick as with person. We said, I don't know what the value is. I'm just gonna call it value. And by putting it in brackets before, I mean figure it out whenever I create something. Whenever I create something, I put something in there, it's gonna have a type, and that's gonna be the type of the data I have. For example, I can do something 3. I call it maybe 3. Oh, is it because of this? Wait, what? Maybe there is a collision somewhere. Let's see if that works. Yeah. All right, so if I do that again, and I zoom in, I can say that it detects that maybe 3 is maybe an integer. And if I do that, and I say it's nothing, it's also going to be happy because it says, well, maybe it's an integer, but we've given it nothing. That's fine because it could be nothing. All right, now the last thing I want to show you is, so where it's always used, the classic example is arrays. So let's change something now. Let's say not only you can have a favorite thing, you can have multiple favorite things. The problem is they all have to be the same kind. They all have to be of the same type. So if you like books, you can have like a top 3 of books. And so this changes our favorites because, well, now we can just do that. Yeah. And now here, Margaret has to be into an array. And now favorites has to be into nothing. This is a bit wrong, but it's fine. And this works the same way as generics. So if you want to write an array of people, you can say it's Jane. Well, there's Jane and there's Mark, and you use this. Oh, just a sec. Jane likes people and Mark likes books. We're just gonna give it. Just gonna give it that. No. this is an array of person, book. Oh. Okay. It's a bit fiddly because now there's multiple layers where it cannot guess what it means. For example, if you say I have an array of numbers, well, what does that mean? Here, it's guessing something, but it's wrong. Can't zoom. Like it says number is an array of any using the bracket syntax. And that's wrong. And even there it says empty collection shall use an explicit type because it cannot tell what is supposed to go there. So you have to tell it this is supposed to be an array of integers. And now that works. When you have, it's the same thing as with nil or nothing. When you say, oh, my thing has a parameter, for example, the value that's supposed to be there, or the favorite thing that the person is supposed to like, and it cannot guess, it's going to tell you, I don't know, I can't guess, you have to tell me. And so here we had to tell that since Mark has no favorite thing, we had to say that it's like someone who likes books. And this one, actually, this was totally wrong because we said Mark is a person that maybe doesn't like something, maybe doesn't have a favorite. And Jane always has a favorite. And that's why I was complaining, was saying, well, you cannot put an array of two different things, people who have a favorite and people who may not have a favorite. And arrays have to be all full of the same kind of values. And that's why we have this parameter, which is say, what is the content of the array? Because if we don't know the content of the array, we can't really go through it. The reason we use arrays is to have collections of homogeneous data. And so array is also, as I use the word parameterized, that's what the bracket, the angle bracket means. This is a type parameter, just like just like a parameter that you set as a preference. You say, well, I want the version of person with books, or I want the version of maybe with ratings, or I want the version of array with numbers. So you give it the parameter, and the language is going to switch over to the right version of the type for you. So that's type parameters and generics and how they're used. This is useful in multiple ways. One of the way it's useful is, for example, if you take arrays and you want to do some operation over them, you don't have to know the content or whatever, or you don't have to know what is specifically inside the arrays. For example, if you do function length, this is a function that will take an array and return as an integer the amount of elements there is. But I don't have to know that this array is an array of persons or books, or persons who like books, or persons who don't have a favorite book, or arrays that contains people who like books. So I'm going to give it a parameter a and say a is whatever the content of the array. I actually don't care. Then I'm going to say, well, for each element in array, I'm going to do increment I by 1. Try it. Oh, and here it says, well, you don't even look at A, so ignore it. And that works. And if I do length of numbers, I should print that. Oh, it's printing. Oh, it's printing Jane. That's why. It returns 0. So let's put some numbers here. So 0, 1, 2, 3, 4, 5. Run, and that should return 6. Yeah. All right. So this I have. Well, okay. Here's the last thing we're gonna see today because we're already running out of time. Functions. I haven't described the function syntax. I just described how to declare types, how to declare values, and how to use them. But now we need to combine values together. So here we combine arrays with integers. We say out of this array, I'm going to get this integer. And the syntax is quite complicated, actually. So to declare a function, you use the word func. Then you have to find a name for your function. So you put it after the name func, the word func. Then you have to put the arguments of the function. So those are the things you're going to use in order to operate. So let's say you want a function that says if your number is 0. So take a number, check if it's 0. What does A0 take? It takes a number. I'm going to call this number. What is the type of number? Type of number is going to be integer. And now you put an arrow and you say, what is the result of this operation? A0 is going to return a Boolean that represents true if the number is 0, false if it's different than 0. Now we're going to put our program in there. And so the program is going to we can do an infinite number of stuff. We can check that number is equal to 0 and then return true. And if it's not the case, return false. That's one possible program, right? And this is the if syntax that says if whatever here evaluates to this value, then execute whatever is in those brackets. Otherwise, execute whatever is in those brackets. And it turns out that we return from the function a value. And return means get the value out. Let's finish the thing. Let's just get it out here. We're done here. Here's the results. And you could also do it differently. You could say, well, if number is smaller than 0, return false. And then if the number is greater than 0, return false. If none of those work, return true. That's also valid. That's another program. You notice that this doesn't have an else block because if you don't put an else block, I will just keep going with the rest. So here we do, is the number 0? No. So we if you do is 0 of 3, execute, and returns false. So I'm going to remove the other prints because it's a bit confusing. We're printing John, which is the value 3. Right, so A0 returns 3. Returns false. Is 0 of 0? True. So our thing is working, it's fine. Wow, this is grossly wrong. Now it's correct. This should be false. There we go. So yeah, just using return statements and ifs we can do the thing, but there is an easier way. You can say return the value of this expression, number different than 0. Wait. Number equals 0. There we go. So is0 can be uniquely defined, well, it can be defined by simply saying equal equals 0. And that's it. That's literally it. So is0 is equivalent to saying equal equals 0. And that works because what we say is return the value of this expression here, and then it evaluates the number. It says, oh, well, number is given 1, then equal is check if it's the same thing, and 0 is not the same thing as 1, therefore we return false, and then this will then return false. All right. I think that's good for today. It's you might think it's a bit simplistic, but it's also quite hard. Like we've gone through really hard stuff. So we've gone through types and generics and functions. We've seen void. We've seen unit. Yeah, that's really hard. I mean, at the beginning. I'm gonna put protocols on hold for next time because protocols are quite a bit harder. They also have something called associated types, which are like generics, but even more finicky because you can't quite tell it to resolve the problems for you. All right, so I'm going to take a break, and I think I'm going to definitely do some Idris, but yeah, we'll see what I do. Maybe I do some state box and stuff instead of research. All right, see you in a little bit.